All right, in this video, we're going to be talking about binary to decimal conversion. And we're going to go step by step. We're going to start out by explaining what binary is, why it's a useful system, and then we're going to jump right into some examples. And we're going to do a few different ranges of examples. I'm going to show an example of converting base 10 numbers the same way, in the same method that we're going to use to convert binary to decimal, so you can get a better understanding. So first of all, a quick note that any number to the power of 0 is going to be 1. Okay, and that applies to any A. A here just being a general variable that we're going to refer back to. So jumping in, we're going to say that binary is a base 2 system, which means that it is represented by zeros and ones. Meanwhile, decimal system, which is what we are most familiar with, is represented by all the numbers reading up to 10. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? All the way up to 10 without including 10. Same way the base 2 is 0 and 1 without including 2. Okay, so binary digits represent powers of 2, and where we start from the 2 to the power of 0 on the left and work our way up. This might sound confusing right now, but we're going to go into some examples where I'll explain what this means. And I want you to think of each binary digit as carrying a weight. Every single digit, every single 1 and 0 has a weight which is attached to it, which we will use to convert from binary to decimal. Okay, so let's see. So if we take an example of a base 10 number, we can break it down as the following. So if we look at a number like 154, okay, we could take the first digit, and this digit carries a weight of 10 to the 0, okay? And then the second digit carries a weight of 10 to the 1, third digit carries 10 to the 2, where this is the hundreds, tens, and the ones, right? You could think of it that way, because 10 to the 0 is going to be 1, this is going to be 10, it's going to be 100. So each digit here has a weight associated with it. And the way that you read this number, obviously we read it as a 154, but if you really want to look at it in a technical term, you can break it down into the following. So it is 10 to the power of 2 times 1, right? So the weight multiplied by the value, this gives you 100. 10 to the power of 1 times 5, which is right here, 5 multiplied by its weight, and then 10 to 0 and 4, where it's the value once again multiplied by its weight. And then you add all of these together, so you get 150 and 4 that add to 154. So this might seem obvious, but if you can break it down and see how a decimal number system is really built up and structured, it'll be much easier to understand how a binary number system is based and structured, and you'll also be able to understand higher structures of numbering, such as hexadecimal or octa value and number systems. So if we look at one more example of this, number 27, once again, the value number 7 has the weight of 10 to the 0, which is the ones, and then 2 has a weight of 10 to the 1, which is the tens. Once again, you multiply the value with its weight and the value with its weight, and then you add them together, and you get a 20 and a 7, which then gives you 27. Okay, so now moving on to what we're actually here for, which is converting binary to decimal. Okay, so I mean, you can see the solution here, but if you want to go ahead and try it before, you can just pick any binary number, and there's multiple calculators online that you can use to check your answers. And I do recommend you practice these, because practice is really what's going to help you just be quick with these, and where you can calculate it without having to break it down like this. So once again, we start by structuring the binary number system as the following. So we start with 2 to 0 on the right with the ones digit, and you just go up in powers. So you go 0, 1, 2, 3, and then you have 4, 5, 6, so on and so forth. In this case, we don't need it. You just need to number the same amount of digits that you have. Okay, so here we have the binary number 1, 0, 1, 1. Okay, so once again, similar to how we did it in the base 10 number, which is just the regular number system that we use on a day-to-day basis, we're going to put the number multiplied by its weight, and we're going to add it together. So as you can see, you have the 10, 2 to the 3 and 1, 2 to the 3 and 1, and then 2 to the 2 with the 0, and then 2 to the power of 2 with the 0, 2 to the 1, 1, 2 to the 1, 1, so on and so forth, and you add these together. So 2 to the power of 3 is just going to be 2 by 2 by 2, right? So it's 2 times 2 times 2, which is just 8, and then like 2 to the 2 is just 2 times 2, which is equal to 4. 2 to the 1 is just 2 is equal to 2. And then 2 to the 0, like anything to the power of 0, it's going to be 1. Okay? So that's where I get the following digits. So I get 8, 0, 2, and 1, and you get an 11. Okay. And something that you should notice here is that any value, whenever you see a 0 in a binary system, you can honestly just ignore this. You don't have to do this calculation. You can only look at the ones because those are the ones that are going to carry weight. Any zeros, you can think of it as an electric signal. This is why the binary system is used in computers. Ones means that electricity is on, and 0 means it's off. So if it's off, then we're not even getting any signal through this. We don't need to consider it. We don't need to think about it or waste our time calculating it. So one more example, actually two more examples. We'll start with a little bit of a smaller number for this one, and then we'll go to a little bit of a bigger number. So once again, you just write the number down right here, 101. You put the weights up on top, and then you multiply. So you get 2 to the 2 times 1, 2 to the 2 times 1, 2 to the 1 with the 0, 2 to the 0 with the 1. You get 4, 0, and 1. You add them, 4, 0, 1. You get 5. Okay? Nice and easy. So now we're going to do a little bit of a larger number. It might look more confusing, but it is not. It is the exact same process. You just keep moving up in powers. So you go 0, 1, 2, 3, 4, 5, 6, 7. Okay, so you can see I just pointed every single one in the direction of where the weight is, just so it's clear. I hope this doesn't look confusing. And then we bring it all together. Okay, so once again, I just wrote a little bit more neatly over here, so you can kind of see it. Okay, so here I just went ahead and ignored any weights where it's 0 because I already know, as I noticed previously, that these will simply just cancel and go to 0, so it is not important for me to look at them. So I simply consider the ones with a 1. So as you can see, we have 1 right here, which is 2 to the 7. We have a 1 right here, which is 2 to the 5. We have 1 right here, which is 2 to the 4. We have 1 right here, 2 to the 1, and 2 to the 0, 2 to the 0. Okay? I know that 2 to the 7 is 128. I know that 2 to the 5 is 32. I know that 2 to the 4 is 16. I know that 2 to the 1 is 2. And I know that 2 to the 0 is 1. Adding all of this together, I get 179. And that concludes how to convert from binary to decimal.